assume interior solution by the marginal rate of chemical substitution between labor and capital is the tangency between the isobond and the isocost line. Then you are able to find the capital and the labor in terms of something. And for capital is in terms of wage, rental rate, and labor. And for labor, you can find from simplifying the tangency condition in terms of capital, wage, and the rental rate. And then, in order to find the conditional factor demand, you must have the Q is equal to L and K's respective cubic root. So, for a particular level of production, Q bar, you substitute K into this production target Q bar, and you are able to solve the compensate factor demand for labor in terms of the rental rate of capital, rate of labor, and of course, you have the production level Q. And once, or I don't put a Q bar because I already explained in hand that this is the production target that the firm has to achieve. And if you substitute L into this, then everything is in terms of K, right? So this allows you to find the compensated capital demand in terms of the rental wage rate and the output level Q. And now you have the compensated labor and capital demand. A cost function is just the wage rate times the conditional labor demand plus the rental rate times the conditional capital demand. And you should find this only a function of what? Rental rate, wage rate, and output. If you do your calculation correctly, you should expect to see a square root somewhere in the punchline. A punchline means the last expression, the last line, or the final result. Now, what you need to do next is, are they homogeneous in R, W, and Q? That means you have to scale both the input prices R and W and the output prices Q by the common factor lambda. Because I haven't used the Lagrangian to solve, I just used the tangency condition as a shortcut. So using a lambda as the common factor wouldn't confuse with anything else. You check whether the conditional factor demand as well as the cost would scale out by lambda or stays the same to check for homogeneity of degree 0 or degree 1. And for part B, now you have to solve for the firm's optimal output level by solving its profit maximization problem. Okay. Okay, my bad. Okay, you do it separately. First of all, you scale out and W by lambda, but keep Q the same. You see whether they are homogeneous in the input prices, keep the output the same, and separately, you keep the input prices the same and multiply it by mu. You do it separately. And then for part B, let P be the output price. Then we find the supply function and the profit function. And the first profit function is the revenue it generates from selling the output Q minus the cost to produce those output as given by the cost function. That should allow you to find the supply function in terms of the output prices and the input prices. And then you substitute this output into the profit function to find the firm's value function, which should only be the function of the price and the price of the output and of the input. Next, you have to show that the law of supply holds. What is the law of supply? When price increases, output increases. That means for the law of supply, it means if the price increases, output increases, and the Hotel's lemma is if you differentiate the profit function with respect to the price, it just gives you back Q. You have to show that these two will hold. And for part C, assuming that the rental rate out increases, show that the cross price effects on labor will satisfy the sum of the output and the substitution effect will add up to the total effect. Now, we have already solved for the conditional labor and the conditional capital demand. What is next is to solve for the unconditional labor and the unconditional capital demand, in which now you have the conditional unconditional one is this one, and the conditional one is RWQ. But Q has already been solved as a function of PRW. So if we substitute the supply back into the conditional factor demand, then you can derive the unconditional factor demand only as a function of output prices and input prices, and you do the same for the capital, in which the unconditional capital demand is to substitute the supply back into the conditional capital demand function in order to derive the unconditional capital demand. Now, is that good? Next, we want to show that the total effect was so funny. The total effect is just to differentiate the unconditional factor demand with respect to the factor prices, because now we just need to check for capital. And the cross price substitution effect is to check whether the conditional labor demand would change with respect to the rental rate of capital. And then what is the output effect? The output effect is to differentiate the conditional factor demand with respect to the output first. LC is RWQ. Then the change in the output with respect to the change in the rental rate. So if this equation holds, the sum of the substitution effect or the cross price substitution effect plus the cross price output effect should be equal to the cross price total effect. You have to check the algebra that this indeed holds. So that the last part asks you how do conditional and unconditional labor demand change in rental rates. Then you just plot the graph I have shown in slides 122, 23, and 24 of the chapter on production theory in order to evaluate this equation in a graph. Okay?